This video provides material from the following two publications. According to theory, there are four fundamental interactions known to exist. But current theory is inadequate in explaining numerous issues, like particular observational data on the expansion of the universe, spiral galaxy rotation not obeying Kepler's laws of motion, why there is abundance of matter over antimatter in the universe, how gravity, as well as inertia and mechanical forces, may connect to the Standard Model, how quantum mechanics may fully bridge with the theory of relativity. And there are numerous other fundamental questions that remain open. If a unifying model existed to address on all these issues, wouldn't this require some form of bridging between the basic interactions? A new model addresses such questions by introducing the existence of inductive-like and capacitive-like phase shifts in all interactions, aside the electromagnetic. New deep symmetry between gravity and electromagnetism, through a particular swapping between certain parameters of time and space. A new way to bring interpretation to imaginary numbers and terms, allowing for groundbreaking innovation. Let us start with an updated approach on how the gravitational force functions.
As it is well known, the presence of mass curves spacetime, which means that time passes slightly slower near a celestial body and faster the further away from it. Let us represent this difference with red and green colors on the hands of the clocks. At living conditions on Earth, this translates in that time passes slightly slower at lower altitude, while it passes slightly faster at higher altitude. And this difference in the fastness of passing time directly relates to the gravitational field that forces an apple to fall. But current theory does not tell how exactly gravity functions, how the difference in the pace of time may drive acceleration of matter. To figure this out, we shall refer to another effect of relativity. Consider a rocket ship traveling in outer space, far away from any celestial matter. The rocket has its engine on, so it accelerates. According to the theory of relativity, for any material object that accelerates, time moves slightly faster in the front part than in its rear part. This is due to a Doppler-like effect developing in the time domain. The clock in the front moves faster by a particular rate, where g is the acceleration, and d is the distance between the two clocks. The very same principle applies for an apple that accelerates while falling. Time moves slightly faster at the apple's lower part as it accelerates downward than at its upper part. In this case, the difference in the fastness of passing time due to acceleration points in the opposite direction and balances out the difference in the fastness of passing time due to the external gravitational field, which is similarly estimated as per the principle of equivalence. Through this way, the potential that the apple experiences in association to the external gravitational field gets relaxed and released if the apple accelerates to fall. This release of potential energy, while accelerating, is what causes this acceleration to develop all by itself, which we perceive as the Earth attracting the apple. In other words, the difference in the fastness of passing time in the environment, which concerns the gravitational field, constitutes an actual potential. As per the new model, this potential possesses potential energy, much like a compressed spring possesses potential energy. By the apple accelerating to fall, the Doppler-like, opposite effect in time, relaxes and releases the external gravitational potential. This release of potential energy, thanks to the acceleration, takes place on its own, much like a compressed spring gets released on its own. It is the same type of principle, only that for gravity, the compression and decompression concerns the time domain. Actually, to confirm that these two processes balance out each other, would require that a free-falling object should feel no gravitational force while it falls. It should feel weightless. And this is indeed the case. Just like it holds in astronauts training in a parabolic flight. The trainees free fall, and while they do, they feel weightless. This concludes the explanation of how the gravitational force functions. On a side note, just like the difference in the fastness of passing time corresponds to a potential, and that may cause acceleration of matter, we shall later figure that it similarly applies with the curvature of metrics other than the metric of time. which may similarly yield potentials and exert acceleration forces on particles' properties aside the mass. In Video 8, we shall particularly explore a deep new symmetry in the action of the electric force via a swapping between real parameters of time and imaginary parameters of space. The manuscript of this work further addresses how the gravitational field may indirectly associate to imaginary parts of a quantum mechanical wave function.